Hello, welcome back. Today we're going to be using the properties of trapezoids and kites. Now, by the end of this video, you should be able to use the properties of trapezoids and kites to find the missing sides and angle measures. So a quick note before we actually start solving the problems. In order to work the following problems, it'd be a good idea to figure out what is shown. Now, what I mean by that is determine which quadrilateral. Think about the properties of that shape that you can use to find the missing information or to answer the question, and then if necessary, write an equation using your properties to answer the question. Remember that all the shapes we're going to look at are quadrilaterals, so the sum of their interior angles is 360 degrees. Let's go and take a look at this problem. It says determine if the quadrilateral ABCD is a trapezoid or not. Now I've went ahead and listed the property that's important for this problem is that in order to be a trapezoid, only one set of sides is parallel. Now if you remember, parallel means that they have the same slope. And all we're given are a series of points. Well, one of the easiest ways to work this problem is to go ahead and plot all these points on a coordinate plane and then find the slopes of all the line segments. So go ahead and on your own paper, draw yourself a coordinate plane and plot those points, pressing pause, and when you're ready to see it graphed on the screen, go ahead and press play and we'll go from there. Okay, so I went ahead and again graphed those points on a coordinate plane as we see here. And what we're going to do is we're going to find the slope between all of the lines. Now, I'm going to go ahead and connect my points with line segments just to show you that it, as of right now, kind of looks like it might be a trapezoid. So yeah, looks like it, but we're not for sure. In other words, in order for it to be for sure a trapezoid, one set of sides has to be the same slope. Well, we can immediately rule out this side and this one right here. They're obviously not the same slope. They're not going in the same direction. But this bottom line here and this top line, those kind of look like the faces of a trapezoid. So let's find the slope of each one of these. Remember that your slope on a graph is rise over run. So I'm going to take this point and I notice I have to go down 1. So that's a -1 rise, and my run is 1, 2, 3, 4. So my run is 4. And my rise is -1. So when we find the slope of that line segment right here, it is -1 over +4. Let's take a look at the other line segment, the one that looks like it might be parallel to the -1/4. In order to get from this point to the point down here, let me go ahead and label those both in green so it's obvious where I'm going. I have to go a rise of down 1, 2. Since I had to go down, my rise was a -2, and my run is a +1, 2, 3, 4, 5, 6, 7, 8. So my run is a +8. This means that my rise over run is a -2 over +8. Now, immediately those don't look exactly the same, but if we reduce this fraction, in other words, divide the top and the bottom of the fraction by the same number, divide them both by 2, we'll get a -1/4. So you find out, yes, one pair of sides does have the same slope, so ABCD is a trapezoid. Now if you're drawing this on your own paper, it may be a little bit hard to do your rise over run, so I encourage you to draw your lines as straight as possible, or better yet, use a piece of graph paper. Now this problem asks us to find the missing angles, and we're looking at the shape. It doesn't tell us what shape it is, so we got to figure that out. Looking at it, obviously it's a quadrilateral because it has 4 sides. It is not a parallelogram because only one set of the sides, these little red arrows that I'm now making black, show that JM and KL are parallel. So it only has one set of parallel sides. Well, if you remember your shapes, that means that this must be a trapezoid. Furthermore, you see these two little lines here, the little dash and this dash? Notice that one pair of opposite sides is congruent. Now, this picture might look a little familiar to the pictures you remembered. It's an isosceles trapezoid. And in an isosceles trapezoid, base angles, this one, and let me outline the other ones in red, this one and this one are the same length. So, if this is 100 degrees, then angle L is also 100 degrees. Well, that doesn't help you much find J and M. In order to find J and M, we know they're the same length, we just don't know what length they are. I'm going to label them both X. Now I know they're both X because they're the same measure. Well, the good news is it's quadrilateral, and the interior angles in a quadrilateral add up to 360 degrees. So I can add up X plus my 100 degrees and my another 100 degrees to give me a total of 360 degrees. So X plus X is 2X plus 200 equals 360. I can subtract 200 from both sides, giving me 2X equals 160. Divide both sides by 2, give me in the end X is equal to 80 degrees, or rather just 80. So we found the missing angles by using our properties of trapezoids, and in particular an isosceles trapezoid. Because these opposite sides were congruent, that meant the base angles also had to be congruent. Let's go ahead and find the measure of a midsegment of a trapezoid. Now, if you remember your properties of trapezoids, you'll remember that the midsegment is the average of the base lengths. Now, we have two base lengths, 28 and 12. Remember, your bases are the two sides that are parallel, and we know these two sides are parallel because of the little red arrows on them, or just arrows on them, period. So the two little arrows on them mean that they are parallel and that there are bases, and that means MN, which is the midsegment, i.e. the segment that's in the middle of the trapezoid, is the average of these two base lengths. So to find the average, we go 12 plus 28, and we divide by 2. So 12 plus 28 is 30, 40. Divide by 2 is 20. This means that our midsegment, MN, is equal to 20 inches. Now suppose we're asked to find the missing angles of, in this case, this shape. It's got a little tail on it. That's always not going to be there. It's kind of a dead giveaway that, hey, this thing's a kite. But how do we know for sure it's a kite? Let's take a look. Notice we have two pairs of congruent sides. But the sides that are opposite or across from each other, they're not congruent. Therefore, this thing's got to be a kite. Now, if you remember, one of the special properties of a kite is that only one pair of opposite angles is congruent. Now, that's going to be important as we try to solve this problem. Well, 140 and 84, those obviously are not the congruent angles that are opposite each other. That means A and C have to be the congruent angles. Well, if A and C are congruent, it makes it a pretty easy problem. We just go X plus 84 plus 140 is equal to 360 degrees. X plus X is 2X plus 84 plus 140 is 224. And we can continue solving this by subtracting 224 from both sides, giving us 2x is equal to 360 minus 224 is 136. Divide both sides by 2, and we should get the angle measures equal to 68 degrees. You can always check your answer by adding 68 plus plus 84 plus 140, and altogether it should give you 360 degrees. Now we're going to be asked to find the value of x for this following shape. Now we look at it, and it's pretty obvious that this shape is a trapezoid. How do we know? Well, we've got one pair of opposite sides that are parallel. See the red arrow right here? The little arrow and this arrow on the bottom? That means the top and the bottom are parallel, so there are bases. And again, one set of parallel sides means that it's a trapezoid. Now, what facts do we know about trapezoids that's going to help us find the value of x? We know that, again, only one set of parallel sides. We also know that the midsegment is the average of the base lengths, and the midsegment is parallel to the base lengths. The property we're going to focus on is the fact that the midsegment is the average of the base lengths. Now you may be wondering, how is that going to help us find the value of x? Well, if we think about what the word average means, we can set up an equation. Now, the midsegment, which is 12.5, means equals to the average of the base lengths. Now, the word average means you add up the two base lengths and divide by 2. Let's go ahead and do that. 3x plus 1 plus 15 divided by 2. And there you go. We've got an equation that we can solve. Now, I know this equation isn't something we're used to seeing, so I'm going to take just a little bit of time to explain how to solve this. We want to get x by itself, but it's trapped in the numerator of our fraction. So we want to get rid of this fraction some way. Notice that the whole top is divided by 2, and we can undo that divided by 2 by multiplying both sides by 2. If I multiply by 2, it's going to undo that divide by 2. Giving me 2 times 12.5, which is 25, equals 3x plus 1 plus 15, which is the same thing as 25 equals 3x plus 16. Now I can solve for x by subtracting 16 from both sides, giving me 9 is equal to 3x, and dividing both sides by 3, giving me in the end x is equal to 3. Now if you want to check your answer, you're like, that doesn't seem really right, you can always put 3 back into x, 3 times 3 plus 1, and checking your answer. 3 times 3 plus 1 is 9 plus 1, or 10. And 10 plus 15 divided by 2 should be our midsegment. 10 plus 15 is 25 divided by 2, which is 12.5. So that was just a quick check to see if our solution really worked. Not necessary, but a good idea to check your work in the end.